Hi, today I am going to prove the gradient of divergence, which is the third equation. Okay, so we will take the gradient of what? Divergence, right? So the divergence is a scalar quantity, and what we do with this scalar quantity, we take the gradient. Okay, so first of all, let's calculate the divergence. So it is gonna be del x vx plus del y v del y vy plus del z vz. Now the gradient of that is gonna be going to be del x cap plus del y cap plus del z cap. Del x vx plus del y vy plus del z vz. So it is going to be for the x component, we're gonna have this del x del 2x vx plus del x del y vy plus del x del z vz, right? Plus for the y component, we're gonna have this del y del x vx plus del 2y, I'm sorry, it is correct, and vy plus del y del z vz, right? For the z component, we're gonna have del z del x vx plus del z del y vy plus del 2z vz. And one thing that we can notice over here is that the gradient of divergence is not equal to the divergence of gradient. Okay, these two are different quantities. First of all, it is a vector quantity, right? And this is a scalar quantity. Right, and it is also it is also not equal to this term. Right, neither it is going to equal to this term, right? Okay, while these two are equal. Okay, so now let's come to the fourth equation, which we are going to prove, which is the divergence of a curl, right? So first of all, we will take the curl of v, which is nothing but it is gonna be del y vz minus del z vy plus y cap del z vx minus del x vz plus del x vy minus del y vx, and the gradient of that quantity, the divergence of that quantity is going to be del so it is going to be, let's write in this way, plus we are writing the del operator acting on this this whole quantity. Okay, so what is it is going to be? It is going to be del x del y vz minus del x del z vy plus del y del z vx minus del y del x vz plus del z del x vy minus del y del z vx. Right, now okay, so this term where del x del z is going to equal to del x del z del x, right, and they have minus and plus sign, so they're gonna cancel out. Similarly, x del y is going to equal to del y del x, so these terms will cancel out, and similarly this term is also going to cancel out, and we finally get 0. So the divergence of a curl is always going to be 0 no matter what the value of this v is, and it also has a very important role in magnetostatic, right? So here instead of v we'll take the vector potential A, and del cross A is del cross A is B, and taking the del dot B is 0, which says that the magnetic monopole don't exist, right? So we will see it in the magnetostatic course. Now the fifth equation is the curl of a curl, right? So curl of a vector quantity is a vector quantity, and we'll take the curl of that vector quantity. So yeah, and it is going to be equal to the gradient the gradient of the divergence minus del square v, right? And we have seen that these and these quantities are not equal, right? So as you can see that this quantity are different. So right, we can prove this term. Let's say take this LHS, which is del cross of v. Now we already know this, what is del cross v, so this is the del cross v. So what we have to do, so let's take this first. Okay, so this is del cross v, right? Del cross of this del cross v is obviously going to be x cap, y cap, z cap. Now del x, del y, del z, and we'll write these quantities: del y vz minus del z vy, and for the del y we're gonna have this del z vx minus del x vz. For the third term we're gonna have this del x vy minus del y vx. Okay, for the x cap we're gonna have this del y del x vy minus del 2y vx minus del z del 2z vx plus del z del x vz minus y cap. So I will just manage this with my y cap. Okay, so del z del y vz minus